Hi guys, this is going to be our math lesson for today. So if you would first start out with your simple solutions packet, we're on lesson 91. I was going to pick out the 6 hardest questions on the packet and go over those. So I circled 5, 7, 8, 10, 12, and 14. If you have other questions, you can always ask me tomorrow. So complete the fraction model to solve 3 times 2 fourths. That's on number 5. So we're going to fill in 2 fourths on each of these fraction models. And then write the number sentence that says 3 times 2 fourths. Well, I'm going to keep 4 on the bottom, and I'm really just multiplying 3 times 2. 3 times 2 is 6. I can also just figure this out by counting my shaded parts, okay? My next question I was going to go over is number 7. Natalie is reading 7 pages a day in her science book. She has 58 pages to read. How many days will it take her to finish them? So that is number 7. So really we're doing 58 divided by 7. Well, I know a multiplication fact that involves a 7 and will get me pretty close to 58. It equals 56. Do you know blank times 7 equals 56? If you said 8, you are correct. So it would take her 8 days to read her science book. So on my square, I would put 8 days. She still has one more page in there. So actually, I'm going to cross off 8 because she actually would have to do 9 days, because since she has a remainder of 1, and maybe she's saying I absolutely will not read more than 7 pages a day, it'll take her actually 9 days. So I apologize. 9 days, not 8. Decompose the fraction 7/8. So if it helps you to draw the picture to help you see, we have the fraction 7/8 is our tape diagram, and I have 7/8 equals, we're going to write that 2 times, and then I'm just going to find 2 different ways that I could add to find 7/8. So I could do 3/8 plus 4/8 equals 7/8. I could also do 1/8 plus 1/8 plus 2/8 plus 3/8. Can you think of another way? If you have a different answer for number 8, I'm sure whatever way you have, if as long as it equals 7/8 is perfectly fine. Number 10, if you stack the 2 tallest blocks on top of one another, what total height would you measure? So our 2 tallest blocks are 4.5 and 5. So I need to do 4 1/2 plus 5. Since my second number doesn't have a fraction, I can keep 1/2 the same. So we're just adding the numbers out front. So 4 plus 5 is 9. Our next one that we're going to do is number 12. Use the distributive property to multiply 43 times 20. So I'm going to do that, I believe, in box 12. 43 times 20. So that's 40 plus 3 times 20. So we're going to be doing 40 times 20 and 3 times 20. And then we're going to add our answers together. Now you might think, well, normally we do a lot more, but since our second digit, the number in our ones place for our second number is 0, both of those answers would just come out as 0 if I multiplied them. So that's why we don't need to do that. So we have 40 times 20, and we have we're going to add that to 30 times 20. So 40 times 20 will give us an answer of 800 plus 3 times 20, which is 60. That gives us a total of 860. So I can rewrite that above there as well. And last but not least, we have 2,082 divided by 4. 2,082 divided by 4. So 2 divided by 4, we can't do it. So let's think of it more like 20 hundreds. 20 divided by 4 will give me 500. 500 times 4 is 2,000. I subtract and I get 82. Well, 80 divided by 4 is 20. 20 times 4, 80. I subtract and get 2 remaining. So I can't divide 2 by 4, so I leave it. My answer is 520 remainder 2. If at any point you need to just pause this video and go back and rewatch anything, please do so. So you can make sure that you have all of your answers. Please make sure you finish the entire page. And also, if you go back and 90 is not completed or 89, please complete those. We are now going to move on to our Eureka lesson. So yesterday I gave you this paper. It says Module 5, Lesson 3 work page. You're going to use this page to fill out your work. So as you work on this video, I'm going to tell you some things to write down. Please make sure you write them down on this paper and turn them in with your work packet tomorrow. So like I said, we're doing Lesson 3. You're going to also have the problem set today. So Lesson 3 starts out with, we're talking about non-unit fractions and representing them as a whole number times a unit fraction, and we're going to use our tape diagram. So for our first problem, I would like you to draw a tape diagram that is 3/4. So let's just call this problem 1. I'm going to put a 1 there. Our tape diagram would be a rectangle that we're going to split into 4 equal parts, and we're going to shade in 3 of those parts. What fraction is represented by this shaded part? Did you say 3/4? I would like for you to say 3/4 decompose as a sum of unit fractions. What do I mean by that? That means we have 3/4 is equal to 1/4 plus 1/4 plus 1/4. So again, I would like you to say 3/4 decompose as a sum of unit fractions. 3/4 equals 1/4 plus 1/4 plus 1/4. How many fourths are there in 3/4? Did you say 3? We know this because we counted 1 3 times. So let's go ahead and just express this as multiplication. We have 3/4. We've drawn it. We've shaded it 3 times. We added 1/4 3 times. So could we multiply 3 times 1/4? Yes, we can. So if we want to add the same fraction of a certain amount of times, instead of adding it, we can multiply. So we are doing 3 times 1/4. So that equals 3/4. Okay, that's our first one. Our second one, let's go ahead and draw our second one. So I'm going to write number 2. So what you're going to draw, I'm going to draw a tape diagram. I'm going to split it into 10 equal parts. And then I'm going to split each one so that I can show those 10 equal parts. And on this, I'm going to shade in all 10 parts. And then I'm going to show that it is one whole when it stops at the 8th shaded part. That represents 1. So if I have it shaded all the way, but our one whole stops here, we have 1, 2, 3, 4, 5, 6, 7, 8 in our one whole. If I have 8 equal parts in our one whole, that means each part is equal to 8ths, okay? So that would mean that my unit fraction is 1/8. So underneath each one, I would like you to put 1/8. How many total eighths do you have? And what is our fraction? So if you said we have 10 total eighths, our fraction would be 10 eighths. So how could we write our multiplication sentence? If you said to yourself, our multiplication sentence would be 1/8, what are we going to multiply it to get to 10 eighths? Did you say 10? 1/8 times 10 equals 10 eighths. All righty. Our next problem, we're going to label it as problem 3. And we're going to draw something that looks like 5/3. So I'm going to draw my tape diagram. It's going to be equal parts. Oh, and I actually have to draw one more square because I didn't make them quite equal. I'm going to shade in all of my parts. And I'm going to stop my one whole at the 3rd square because I'm showing thirds. So right now we have 5/3. How could I write it in an expression of unit fractions? If I write it as a sum, I would write 5/3 equals 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3. If I write it as a multiplication sentence, I could write it as 5/3 is equal to 5 times 1/3. Now I want you to pause. Can it also be written as 5/3 is equal to 3 times 1/3 plus 2 times 1/3? If you said yes, how do you know? 3/3 times 1/3 is equal to 3 times 1/3 is equal to 3/3. And 2 times 1/3 is equal to 2/3. If I add 3/3 plus 2/3, I get our answer of 5/3. So what I would like for you to do today is you have your problem set. You have your problem set. Now, so we've used this page. This was the teaching I did for this lesson. What you are going to then do is do the same thing, but you're going to be doing it on your problem set. So let's follow the directions. It says decompose each fraction model by a tape diagram as a sum of unit fractions. Write the equivalent multiplication sentence. The first one has been done for you. So let's just take a look. So they show in this fraction 3/4. So we have 3/4 is equal to 1/4 plus 1/4 plus 1/4. I can also write it as a multiplication sentence of 3/4 equals 3 times 1/4. Now let's check out this next one. I'm going to do B with you. B, we have 5 pieces. So that means my fraction is fifths. And I have to look how many of those fifths are shaded. That's 2/5. So my unit fraction for fifths is 1/5. How many times do I have to add 1/5 together to get to 2/5? 2 times. So we have 2/5 is equal to 1/5 plus 1/5. It is also a multiplication sentence of 2/5 equals 1/5 times 2. So you are going to do the front and the back. Now, the second one, write the following fractions greater than 1 as a sum of 2 products. So I'm going to do the first one for you. So remember, as a hint to show what fraction, what unit it is, we have to kind of cover where the 1 stops, and I can see that there's 3 equal parts. So I have thirds, and how many thirds do I have? I have 1, 2, 3, 4, 5. I have 5 thirds. So they're saying as a sum of 2 products. That means I have to do 2 different multiplication sentences. And I'm adding those 2 together. So what are 2 ways I could do that? I could do 2 times 1/3. I have to have unit fractions, and then plus 3 times 1/3. How do I know that those are the answers? Because 2 times 1/3 will give me 2/3, plus 3 times 1/3 gives me 3/3. So that is how you do A. You're going to do B on your own. And then on the third part, it says draw a tape diagram and record the given fractions decomposition into unit fractions as a multiplication sentence. So I will do A, 4/5. I'm going to draw my tape diagram because that's part 1. I'm going to split it into 5 equal parts. And I'm going to shade in 4 parts. Now it says decomposition into unit fractions as a multiplication sentence. So what is our unit fraction for fifths? Did you say 1/5? How many times do I have to multiply 1/5 to get to 4/5? 1/5 times 4 will give us 4/5. So that is what you have to do for A through E. So you're going to do the entire problem set. Okay, so I'll go through. I went and I did B for you. You need to do C, D, E. You also need to do B, C, D, and E. Now, the ones I didn't circle should be done already. These are the ones that you are doing independently without my video. Let me know if you have any questions. Bye, guys.